Now we will discuss one of the very simple experiment that is generally done in the food industry, as well as you might have done this in your previous classes as well. This is the determination of titratable acidity of fruit juices. So first of all, let's see why we would do this analysis. Generally, foods, especially fruits, when they are mature, they would have different acidity level. So initially, as you might observe, that they are sour in nature, and gradually they would have more sugar content. They are more sweeter in nature, and this they are less sour. So that means their acidity generally is declined when they reach to a maturity stage. So it is important to know at what stage they are edible and what is the maturity stage, based on the information that how much acidity they have. And same is true with the fruit juices. If you have to make them, they must uh, they must be aligned with the tritable acidity of natural fruit juice or natural fruits, so that you give a natural taste of coming from these food products. So if we talk about the principles for measuring the titratable acidity, we have to use known amount of food sample, and we have to titrate this with a known amount of base with known normality, and the quantity, of course, would decide how much acidity is there in the final solution. So the volume of the titrant, it has to be looked into it, and the normality of the base as well. And we have to look at the volume of sample that is used. These all factors, once they are known, we can calculate the titrable acidity of fruit juices. It is expressed in terms of predominant acid present in certain fruits. For example, if you have citrus fruit, it would be citric acid, which is the predominant acid present. So this acidity has to be determined on the basis of molecular weight of citric acid. And similarly, in case of apple, the predominant acid would be malic acid. So we have to look at the kind of fruit that we are measuring the titrable acidity, and then we have to take the predominant acid present in that fruit for the calculation of acidity purposes. pH is also used as an endpoint. As you might know, that once you titrate acid with base, there would be a point when it becomes to a near neutral situation, and which we would be having different indicators. They would change the color, and we would get to know that all the acid or base has been consumed by the acid base reaction. So pH can also be, as I said, that the indicators that we used, they would change their color once a desirable pH is attained, and from that change in color we would come to know the endpoint of titration. So generally we would use two most commonly used indicators. This is phenolphthalein indicator and bromothymol blue indicator. If we talk about the chemistry of all food acid, they are all weak acids, and they would have their relevant salts present in those fruits at the same time as well. And these salts would have a buffering action on these fruit products or fruit based products. But at the time when the indicator, this for example, this phenolphthalein indicator endpoint, at this stage, because we have consumed most of the acid present in these food sample, so the buffering action is not visible, or it doesn't happen at that pH range in which the phenolphthalein would change its color. So as I said, it would be changing its color from clear to red in pH range 8 to 9. So that would mean that we have an acid, maybe in a flask. We titrate that against a base, and once all the acid has been neutralized, the pH would go towards alkaline, and at that alkaline pH, for example 8 to 9.6, the color of phenolphthalein would be changed. So that change in color would tell us that all the acid has been neutralized by addition of base from the burette. And Contrary to this bromothymol blue, it has to be used when we have to use base in a flask and we titrate that against acid. So that would change its color at the pH 6 to 7.6. So when all the base has been neutralized and there is a small amount of excess acid added into the flask containing food sample, that would change color to blue, and that would tell us that the acid base reaction has been completed. There could be a problem in certain fruit juices where they have got dark color. For example, beetroot juice or maybe some of the citrus juice or other food products which have got their own inherent dark color. So in that case, it would be very difficult to look at the endpoint because the endpoint of phenolphthalein or this bromothymol, that might interfere with the color and we cannot see the endpoint. So we have to use this potentiometric method, or in other words, I can say we have to use the pH meter, and we have to look at the point at which the pH has been neutralized. Um, as you might know that we have to add a small amount of base or titrant gradually so that we can come up to a point where we exactly neutralize acid and base in this reaction. So most commonly sodium hydroxide is used. Before using this sodium hydroxide, we also need to know the exact normality of sodium hydroxide because there might be error while making these solutions. So in order to standardize this sodium hydroxide normality, we have to titrate this against a standard acid. For example, potassium acid phthalate. It has to be used for standardizing this sodium hydroxide solution. Then another precaution has to be taken that you would use an aliquot sample of this fruit juice that has to be titrated. So this aliquot or blank solution has to be taken, and we would be treating this the similar way as we titrate the sample containing fruits. And there may be some amount of sodium hydroxide that can be that has to be extracted in the final reading. The calculation, if you look at the calculation of titratable acidity, this is the formula. We have this formula would give you the percentage acid weight by weight basis. So it would be achieved by multiplying the normality of titrant with the volume of the titrant with the equivalent weight of the predominant acid present in that specific food sample that we are dealing here. It is divided by mass of the sample, that is capital W here, and 1000 is a factor that would tell you the amount of acid in milligram per gram in the food sample. So this was the method how we measure titrable acidity in different fruit juices, and the same can be applied for any general acidity measurements in other samples as well.